Yeah, good. It's a number, a variable, or a product of a number and one or more variables. That's a monomial. And then a polynomial could be a monomial, or a binomial, or a trinomial, or what do we call the rest of those? Just polynomials. So you're going to have one monomial, and then you're going to have something else. So that's the point of this title. And we're just going to go straight to the first example because really you just do it based on the different rules we looked at in the past. So example 1a, 7b times 4b squared minus 18. And can somebody raise your hand and tell me what is the monomial in this expression? What's the monomial? Josh? 7b. 7b is the monomial. And what's the other polynomial? I'm saying other polynomial. Benson?
4b squared or minus.
Yep. Good. This whole thing in here, what kind of polynomial is this inside the parentheses, by the way? Binomial. And I'm going to keep going over these things because guess what your next quiz is about? I'm going to have two quizzes for this chapter. But the next quiz is on what kind of polynomial is that? What kind of polynomial is that? Okay. So you guys notice, is there multiplication going on here? Okay. Which property will allow me to multiply correctly? Distributive property. The reason is this. When I first introduced distributive property, you guys, last year, I think I heard or saw a lot of you like, why do we have to distribute? Why don't you just add these two and then multiply by the number outside? Well, what's our problem here? They're not like terms. Can you combine these anymore? No, so now you have to use distributive property. So what we're going to do is this, and be super careful because it's very easy to add a variable, take away a variable, or put the wrong exponent. I'm going to multiply 7b by the first term in that binomial, 4b squared. Okay, what's 7b times 4b squared? Deal with the numbers first. What's 7 times 4? 28. So we got that part. What's b times b squared? B to the third power, or b cubed. Good. That's it. 28b cubed. Okay, now, yes, sir?
So with multiplying and like dividing these things, they don't have to be like terms, but
Exactly. Yeah, when you're adding or subtracting polynomials, they have to be like terms. If you're multiplying or dividing, they don't have to be like terms. In this case, nope, not like terms, but you can still multiply. So yeah, you got to distinguish that. Good point. All right, what's the second term in this polynomial inside the parentheses? Negative 18, and I'm emphasizing negative 18. So it's 7b times negative 18. So you're like, what's 7 times 18? Yep.
wait, no.
So it's 70 plus 56.
It's 126.
126. Okay. Minus 126 is the number. And then what variable should come after it? Well, what's b times b to the 0? You could even say. This is b. And just make sure your b and your 6 don't look the same. You have just multiplied the monomial by the polynomial. That's it. That's what you're doing this lesson.
Alright, let me get your homework.
Yeah, I wish. Okay, let's look at another one because it can get more complicated. We're still going to multiply a monomial by a polynomial, but it depends on the signs and how many terms. That will make this a little bit tougher. So negative 3y squared times, I keep looking at the wrong, 6y squared minus 8y. And then plus 12. Okay. So where's the monomial, Kyra? What's the monomial?
Negative 3y squared.
Good. Negative 3y squared. James, what is the polynomial?
6y squared minus 8y plus 12.
What type, good job, what type of polynomial is that inside the parentheses, Harper? Trinomial. It has how many terms? 3 terms. All right. If it has 3 terms, how many times do you have to multiply? 3 times. Okay, you're going to multiply negative 3y squared by the first term, positive 6y squared. So what's Negative 3y squared times 6y squared. Well, what's negative 3 times 6? Negative 18. What's y squared times y squared? Y to the fourth. You just added those exponents. Do you remember we dealt with the rules with when you're multiplying like bases, you add the exponents? That's what we're doing right here. All right, the next term inside the parentheses is negative 8y. What's negative 3y squared times negative 8y? Good. Positive 3 times 8, 24. Y squared times y? Y cubed, or y to the third. Good. And then the third term is positive 12. What's negative 3 y squared times 12? Negative 36 y squared. Okay, and just to make sure, can I make this any simpler? Really? I thought I could combine these two. They both have y. Wait, I thought you're allowed to multiply unlike terms. Why can't you add unlike terms? Well, adding and multiplying are not the same. Can I combine these two together? These two? These two. Oh, man. You guys are so picky. Okay, that's my answer. Yeah, that's good to be picky in this case. How many of you are kind of getting this? I think I'm going to go all the way here because you guys are doing really well. How many of you kind of maybe struggling a little bit with not multiplying the numbers, but maybe the variables? Okay? All right. Let me give you one to see if you guys are getting it. On page 532, let's go with, okay, number 14. Start you off on a nice light one, and then I'll throw you a challenging one. You guys okay? I have a cure for that, by the way. It's very simple. It's an even cure.
Don't drink water.
Something like that.
He has to stay in game though.
Yeah.
He can't leave it.
Yeah.
It's a tough one.
Impossible.
Okay, who can tell me what you did to get your answer? Well, actually, I keep saying who can, but let me just pick. Eli, how'd you get the first term in your answer?
Multiply 7 by 2, and 14, put x in it.
All right, how to get the second term, Lisby?
You like multiply negative 7 by 9.
Mm-hmm.
Get negative 62.
Yep, negative 63. Is there any way to combine those two terms? No. So you're done. That's your answer. Simple enough?
Yes.
All right, you guys need a tougher one. Number 9 up above.
No.
And notice the instructions say to simplify. And I love that instruction. It's one word, period. Simplify. That's it. Make it simple. Katie, what'd you do first? And what'd you get? 3w squared. Good. Taylor, what'd you do next?
Multiplied w by negative 5.
Mhm.
We got negative 5w.
Great. Yes.
Last stop.
Yes. Walker. Yeah, plus 3. Oh, yeah, I forgot. Oops. Sorry about that. Wyatt, what do I do next?
You add
What? Add what?
negative 5W.
Okay, what's negative 5W plus positive 3W?
Negative 2W.
Negative 2W. 3W squared minus 2W, or you could have said negative 2W plus 3W squared. Either one's good. On a scale 1 to 10, the difficulty of this problem on this lesson was a 4. You want a tougher one? Great. Yeah, it gets a little bit tougher here. Let's, wow, that's not even that tough.
39.
Let's go back to example number 2. Just notch it up once, example number 2. And then if you're looking at the next example, it can get, example 4. That one can get a little bit complex. Don't worry, you'll be able to handle it. Just let's go one step at a time. Example number 2. Beth, can you read that problem for me? Example number 2, negative.
Okay, find negative 3p cubed and parentheses p squared q plus 2p minus 3p squared q.
Okay, thank you very much. All right, so this one, just a little bit tougher just because you have the p's and the q's and they have different powers and you're multiplying, so you got to add the exponents. That's a mouthful. So just write it down and then see if you can work it out real quick. There are 2 ways to work this out. There's an easy way and there's a tough way.
Do the tough way.
I like the tough.
I like the tough
Guess we'll find out.
Oh, okay.
If you took longer than 10 seconds, you did the tough way.
Okay, I'm
just
doing
kidding.
the tough
I'm just
way.
kidding. There is a way you could do it to make it maybe easier for you, maybe not, but either way, you should get to the same answer.
Ooh, you can simplify within the parentheses.
Yeah, look at the parentheses. Look at the 3 terms. Are there any like terms inside the parentheses? Oh, man, yeah, there are. These 2 are like. I can add them first. Then I multiply. So I'm going to get negative 3pq. That stays the same. And then what's pq squared minus 3pq squared? Negative 2p squared q. I think I was saying it wrong, but hopefully I wrote it correctly. Plus 2p. And then I can go ahead and distribute. Could I distribute, then add like terms? Yes. And some of you did that and you still get it. Okay, Vivian, I don't know if you did it this way, but you can look up here. What's negative 3pq times negative 2p squared q? Vivian.
6pq and
Q squared. Oh, man. Got to keep track of all your exponents because it does throw off the answer. And then, Lizzie, what's negative 3pq times positive 2p?
negative 6p squared.
Yep, p squared q. All right, are those like terms? No. Oh, okay. Can't combine them, you're done. You guys get that? How many of you did the distributive property here, here, and then here 3 times? Did you still get this? Good. We're happy about that because you could do it either way and still get it. Okay, that was a difficulty of like maybe 5 or 6. I don't know. Should I do this next one? Yes. Go back to page 532. I want to see if you guys can handle number 10.
Yeah, we can do it.
Way to do it.
Oh, I'll take that. Thank you. And maybe you'll watch the video up to the 14-minute mark, and then the rest you should get. So number 10, I just got to make sure I write it the right way. Question? Okay. I'm looking at it thinking, all right, I want to simplify inside the parentheses if possible. If not, I just start distributing. Page 532. Scale 1 to 10, I think it's a 7 or 8.
We're gonna get to a 10 on this one?
11.
Ooh.
No, we'll get to a 10.
Oh.
Okay, if you are not sure what to do, I can work out that first step and then hopefully you're pretty good on it. So I'm going to do 4y times 2y cubed. That's 8y to the fourth. And then I do 4y times negative 8y squared, negative 32y cubed. Then I do 4y times positive 2y, positive 8y squared. 4y times 9 is positive 36y. So that's the first expression simplified. Then I got to do the second one. What's negative 3 times y squared? Negative 3y squared. What's negative 3 times positive 8y? Negative 24y. Now you do the rest. Hopefully you can do it.
Is it like when you guys said negative 3y? Is it like subtracting like
The whole thing?
or is that like one whole?
It's like one big thing. And you notice that you're doing distributed property here. And the last lesson had the same thing except without the 3, you're technically multiplying 2, which is cool. But I'm not going to confuse it with that. You multiply it negative 3 by both of those. All right, like terms to 8y to the fourth. No. Negative 32y cubed. No. 8y squared. Negative 3y squared. And 36y. Negative 24y. Okay, so we got to be careful here. I'm just going to write the ones that don't have like terms. All right, what's 8y squared plus negative 3y squared? Positive 5y squared. And what's 36y minus 24y? Positive 12y. And once you get your answer, what order did I write my answer in? I'm just curious because you're going to have to do this. Raise your hand. Hayes. Descending order of descending order of the powers of y. Okay? Normally, what are we doing with x? But you can deal with y. This is descending order. Could you write it in ascending order?
Yes. We should be doing this in a lesson.
No, you don't have to write it in order unless they say it. Soon they will. But no, you can just put it in any order. Just make sure that you... By the way, I think it's easier to grade when you do have it in order, whether it's ascending or descending, because you can just follow the exponent and not have to look all around for it. How many of you got that? Okay, good. And if you didn't get it, maybe you could see it was a sign. Maybe you multiplied incorrectly with the numbers. But hopefully you can correct that out. Okay. That can't be. Example number 4. What's the difference between example 4 and, say, example 2 or the one you just did? Sorry, what's in there? Equals what? What kind of expression has an equal sign in it? It's called an equation. Yep, an equation. So that means you have to do what? It says right there, one verb, solve. I got to find out what x is. Which one? Okay. Taylor, can you read for me the problem? Solve and then...
Solve x, parentheses, x plus 3, parentheses, plus 7x minus 5, equals x, parentheses, 8 plus x, parentheses.
just didn't fit in there. That's a 14 in there. Yeah, it's a long problem. Okay, what you're going to do is you're going to simplify first. You're going to simplify both sides of the equal sign. That's your first step. Get it as simple as you can get it. So what do I have to deal with first when I'm simplifying? The parentheses. I want to deal with this first on the left. So what's x times x? X squared. What's x times 3? Positive 3x. So that's what we've done already. And then I still have that positive 7x minus 5 on the left. The right side, I want to get rid of those parentheses. So I'm going to get 8x plus x squared, and then I still have that minus 9x plus 14. Oh, man. That made it slightly simpler, but that's still confusing. When you add like terms, you have to do it on both sides of the equation. Don't mix these terms here on the left with the terms on the right. So here I'm looking for like terms. Oh, nice. I get x squared plus 10x minus 5 on the left side. And then on the right side, I got x squared minus x plus 14. Ugh. That already looks tough to me. Solve for x. Wait, the x squared or the x? What do you notice about the x squared? Something you could do to it. Yeah, it has a 2 exponent. We haven't ever solved for x squared, but for a few problems. And you're not going to have to do it today either. Because guess what you could do to that x squared? I subtract it from both sides. Let's see what happens. Oh, man, it gets rid of it. Oh, that's a good thing. So 10x minus 5 equals negative x plus 14. Now I can solve that, just like I've normally done it. And there are many ways to solve it. You get the x to the left, you can get the x to the right, then get it all by itself. I'm going to add x to both sides, so it gets rid of it on the right. And then I get 11x minus 5 equals 14. When you're adding like terms, the variables and their exponents don't change. Okay, so I add 5 to both sides, I get 11x is equal to 19. And then I divide both sides by 11. What? 19 elevenths? What's that? What's it about? About 2, a little under 2. That's all it means. Right, 22 elevenths? Yeah, 1 and 9 elevenths. What would...
1 and 8 elevenths.
Yes, you're right. Thank you. That's okay. It's a little under 2. If it were 22 elevenths, it would be exactly 2, but there you go. 19 elevenths. So if you had the time, and I'm not asking you to do this, if you had this original expression, you know what number fits in each one of these x's? 19 elevenths, okay? That's the number that fits. Scale, 1 to 10, you don't have to, it's up to you, is 9.2. Okay. No, that's it. No, there might be some tougher ones, but just be careful. There might be a 10 in there somewhere, a few of them, I don't know. You guys good on that?
Yes.
Good. I'm going to have you solve this last one. If you can do it, you guys are set. Number 12. The ultimate final test to see if you get this stuff. Number 12. I went from here to here to follow my work. Sorry. Thought of these problems. Okay, if you're not done, it's okay, but anyone want to share their answer for X on number 12? And share it with your neighbor. Show them what you got, see what you got, see what they got, see what you got. Look at it again, see if you got the same thing or different things. Hopefully one of you got it right. Maybe both of you got it wrong. It's possible. All right, the answer is X equals 1/2. 1/2. You got a negative?
I got a negative 1/2. I got it right.
Okay, can I look at it when I give the homework? I just want to see what happened.
I think you had -7 over -15 and you didn't.
Yeah, I think that's
Yeah.
Okay, good. All right. What's nice about these problems is, especially like on a quiz or test, as you show your work, you can pinpoint right there. That's where the mistake was. If you show your work, which it's really hard not to. Okay, your homework is going to be, today's Thursday, 15 to 25 odd. (26 to 31). Numbers 40 and 41. And that is on page 532. I'll write it up here. 15 to 25 odd. Uh, 26 to 31. That's all, by the way. 26 to 31 all. And then numbers 40 and 41. Yeah, I actually thought it would be too complicated, but you guys handled it well. Oh, interesting. Can I make an edit?
He solved for X more
Like you've done that a lot before.
yeah.
It just got more complex, yeah. That's actually good. I'm glad you guys could do it. Numbers 40 and 41, do you remember those? They're not circles, thankfully. They're not weird rectangles. They're just straight rectangles and a square in one of them. And I want you to try those out. So here's what you would do. Can I help you out on number 40?
Yes.
You want to find the area of the shaded region. So if I take the rectangles area and I take the little rectangles area, what would I do with those two areas? Subtract them. So how would you find the area of that big rectangle? Wait, how do you find the area of a rectangle? Length times. So do you have a length of 3x? Mm-hmm. Do you have a width of x plus 2? Multiply those two together. So you multiply those together. And then for that little rectangle, can you find the area of the little rectangle? Well, what's the length of the little guy? 2x. The width of that? X. Can you do 2x times x? And then what do you do with those two products? Subtract them. So try it out. Do your best. See how you do. Goodbye, Sue.